Standard form is one of the maths tools we have to be able to use at GCSE Science, and it's there to deal with really big or really small numbers. The problem with really large or very small numbers is, first of all, if you're trying to tell somebody what that number is and you end up saying 224, 00, 00, 00, and so on, it's very easy for somebody to miss what you're saying. It's also very easy if you're copying the number from one place to another to miss a zero out or add a zero in by accident. So it's very clunky and it's prone to errors. So standard form is a way to get around this. What I'll do to start with is have a look at how we apply it in maths. So it looks exactly the same as you would see in your maths lessons. And then I'll show you how we apply it, particularly in science. Let's do a quick recap on indices then. So we already know that if I've got 10 squared, then that's going to be equal 10 times 10, which is 100. If I have any number then to the power of 3, so 10 to the 3, I multiply it by itself 3 times, and that gives me 10 times 10 times 10, which is 1,000. So 10 to the 4 is 10,000, and 10 to the 5 is 100,000, and so on and so on and so on. Let's add another layer to that now. If I had 2 times by 10 to the 2, then I know that 10 to the 2 is 100. 2 times 100 is 200, nice and easy. If I have 4 times 10 to the 3, okay, we know that 10 to the 3 is 1,000. So I've actually got 4 times 1,000, which is 4,000. I can make it slightly more complicated using decimals. If I have 2.9 times 10 to the 4, we know that 10 to the 4 is 10,000. And if we put that into a calculator, we'd end up with 29000 at the end. And then finally, if I put 3.2 times 10 to the 5, we know that 10 to the 5 is 100,000. 3.2 times 100,000 is going to give us 320,000. So that's how we can convert what looks like a standard form into the large number. But what about going the other way? We're going to start with the large numbers first. So here's an example, 254000. I'm going to start by going to the number on the left. That's the number with the biggest value. And by biggest value, what I mean is if I look at this number here, this is units, then we go to tens and hundreds, thousands, 10,000s, 100,000s. So by biggest value, I mean we're looking at the bit which has, in this case, hundreds of thousands. The next thing I'm going to need to do is make a number between 1 and 10, starting from the left. So, for example, if I were to choose 254, 254 is not a number between 1 and 10. Okay, it's too big. Similarly, if I were to take 25.4, okay, and just use that, that would not be a number between 1 and 10. So if I'm going to get a number between 1 and 10, I'm going to select and put a little decimal point between the 2 and the 5 and turn that into 0.54. That's now a number between 1 and 10. When we first wrote down the number 254000, we didn't bother with a decimal place because there weren't any numbers to go after it. But we know in reality it exists here. Okay, there's just nothing to the right of it at the moment. However, in the last slide, I moved the decimal point so that I could have a number on the left-hand side that was between 1 and 10. So what I need to do now is work out how many places that I need to move that decimal point in order to get it from where it started to where I've moved it to. So what I'm going to do is I'm going to make it jump once, twice, 3 times, 4 times, 5 times. Now rewrite the number as 2.54 multiplied by 10 to the 5, and this is what we call standard form. The 2.54 is the number between 1 and 10 that we identified, and the 5 is there because we moved the decimal point 5 times. Now pause the video and have a go at these 4 examples, and the answers will appear in a few moments. So first of all, we need to identify that 4.3 is a number between 1 and 10. Having done that, we then need to see how many times we've moved the decimal place. So it's gone once, twice, 3, 4, 5, 6, 7 times, and hence it's 4.3 times 10 to the 7. This time we've got 6.09 is the number between 1 and 10. Don't forget that little 0, it's very tempting to do that. And again, we've got to count the decimal places. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us 6.09 times 10 to the 9. So 1.53 is now a number between 1 and 10, and we're going to go 1, 2, 3, 4 decimal places, giving us 1.53 times 10 to the 4. And finally 7.7, and then we're going to work out number of decimal places again, 1, 2, 3, 4, 5, 6, giving us 7.7 times 10 to the 6. With the small numbers, we're also going to start by looking for the number with the biggest value. Again, it's the leftmost number, but it's the leftmost number which isn't 0, because obviously we could start with 0, it doesn't really tell us anything. So the biggest value number is 6. Again, we need to make a number between 1 and 10. And again, I think we know that 657 is not between 1 and 10, so we're going to have to find a different number, and I think we've probably got it by now. It's 6.57 is the number that we're going to use. As with the large numbers, we need to count how many places we've moved the decimal point. So we started here and we've got 1, 2, 3, 4, 5, 6 places. So our answer is 6.57, so that's the number between 1 and 10, multiplied by 10 to the minus 6. The 6 is the number of times we had to move the decimal point. The negative bit tells us I've moved the decimal point the other way. We went from left to right this time rather than right to left. Or if it's easy for you to remember, if it's got a negative there, it's a small number. If it's a positive, it's a big number. Now pause the video and have a go at these 4 examples, and the answers will appear in a few moments. So question 1, we're going to use this bit here to give us 5.2 as our number between 1 and 10, and then we're going to count our decimal places, 1, 2, 3, 4, 5, to give us 5.2 times 10 to the minus 5. Here our number between 1 and 10 is 1.36, and if we count our decimal places, we've got 1, 2, 3 points, so it's 1.36 times 10 to the minus 3. So we're going to make our number into 2.5. There's our number between 1 and 10. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 times, which gives us 2.5 times 10 to the minus 9. Here we're using these numbers to give us 2.94 is our number between 1 and 10, and the decimal place has moved 2 spaces. Let's look at an example now then. This is a very typical question that you might get on a GCSE paper in the wave section. We're asked to calculate the frequency of the light wave with a wavelength of 4.5 times 10 to the minus 7 meters, and the speed of light is 3 times 10 to the 8 meters per second. Now it's important to note that you're actually expected to know this, okay, particularly if you're doing higher tier. So we're going to use the wave equation, V equals F lambda, so wave speed equals frequency times wavelength. And I've put the numbers in underneath already. So I've got V is 3 times 10 to the 8, lambda I've put in as 4.5 times 10 to the 7, and we don't know the frequency at the moment. And now finally we need to rearrange the equation, so we're going to do reverse maths. Because we've multiplied on this side, we're going to have to divide on this side, so I've moved this bit here underneath to do 3 times 10 to the 8 divided by 4.5 times 10 to the minus 7, and when I do all of that I end up with our overall answer here, which is 6.67 times 10 to the 14 hertz. Is a particularly large number. For our second example then, we're going to calculate the wavelength of a microwave with a frequency of 3.2 times 10 to the 11 hertz, and again the speed of light is 3 times 10 to the 8 meters per second. We've got the wave equation down there already, V equals F lambda, and now I put the numbers in underneath, so we've got our speed of light in here, and we know our frequency this time is 3.2 times 10 to the 11, and lambda, wavelength, is the bit we don't know. Finally then, we need to rearrange the equation. So I've brought 3.2 times 10 to the 11 down to the bottom here. I've divided through. When I do that, I end up with this answer here, 9.34 times 10 to the minus 4 meters. Now you'll notice that in both answers here, I've kept this part of the number here to 2 decimal places. In fact, you have a much longer number of decimal places on your calculator. I'd recommend sticking to 2 decimal places as a rule. It keeps it much neater. You don't really need to go any further than that. Okay, hopefully you've got an idea now about what standard form is and how to use it and how it will be applied in the waves topic. Okay, good luck.